So hey everyone, welcome back. I hope you guys are doing extremely well. So today we are going to solve a bi-weekly contest, and this is the first question. Uh, let's understand what the question is. Minimum number of operations to have distinct elements. You are given an integer array. In one operation, you remove the first three elements of the current array. If there are fewer than three elements remaining, all remaining elements are removed. Repeat this process until the array is empty or contain no duplicate values. Okay, return an integer denoting the number of operations required. So the problem statement is quite clear. It's easy to understand. Let's see the example. So this is our example, and what we have to do in one operation, we can remove three first elements, and for the rest of the one, we just have to check if they are distinct or not. If it is not, then again we pick three more elements and do the same operation until either our array is empty or either the number of elements are distinct. So if you see in this example, if in the first operation we remove the first three elements, the remaining elements is 658 and all are distinct, so we stop, only one operation is needed, right? So this is basically the problem statement is like, if you see, every time what we have to do, we have to just remove the first three elements, and like if we remove first three elements, so 3 8 3 6 5 8, after removing three elements, sorry for that, we only have these elements, and if you see, all were are unique, right? So how many operations we actually required? We just required one number of operation to achieve such answer, right? So how to actually solve this particular problem? The problem statement is uh, really easy to understand. uh, how to just actually, how to actually think of and how to actually approach this particular problem. So if you see, what we have to do is, every time we just have to pick uh, first three elements and remove them, and for the rest of the one we just have to check if they are a unique or not. So the brute force way is, if you talk about brute force, so what we can do is, first like take remove these three elements, and after that we just check the remaining elements are distinct or not. If it is not, then we again take the next three elements. Let's say for first case, we take 383, right? And after that, the number of elements remaining is 658. In this case, they all are unique, so we do not require more operation. But what if the remaining elements are like this? In such case, if you see, even after removing these number of elements, like these elements, we still have duplicate elements in the remaining area, right? So what we have to do now, we again pick three more elements and remove them, and after that we check if these are distinct or not. So this is the brute force approach. In this example, output will be 2, because we have removed two consecutive elements, like I'm talking in terms of three a pair, right? So in this scenario, we require two number of operation to achieve array which contain distinct number of elements, right? So the brute force is quite simple. Remove first three elements, then check for the rest of the one, then again remove three elements, then check of the rest of the one. But we are doing the same thing again and again. If you see, it's sort of like, uh, in worst case, we can understand it's like going to be an of and square, because every time we are iterating our on array. So it is not an optimal approach. In order to solve this optimally, how we can solve it, right? So if you see, whenever there is a concept of duplication, so we always care about the frequencies of the elements, right? So what we can do, so the one thing which I'm thinking right now is, uh, what we can do, uh, if we have a keep track of number of elements of with their counted, right? For example, 3 occurred two times, 8 occurs two times. I'm taking this particular example, right? And similarly, we have 6 which occur one and 5 which occur once, right? So if we have this data with us, so how we can use this particular information to solve this problem, right? So as we know, every operation, what we have to do, we have to remove first three elements, right? So this is the operation which we have to perform. So why not store these number of these data in somewhere, and iterate over our array and take for the like whenever we are going through the element, we just simply check if it is present in our particular data structure, whatever we are the map which we are using. If it is, then we simply decrement their count, right? It become 1, which gives us an idea that we have removed one element and there is one more element which is still exist in our array, right? So but we have we remove one occurrence of that element, then we move to 8, right? 8, we remove its frequency as well, then we move like reach at 3. As we know, we remove one occurrence of 3, but still we have one more occurrence, so we simply remove the occurrence of 3 as well. And if any number count becomes 0, then we simply remove it from our map because it doesn't contribute to our answer, right? After that, if you see, I have removed uh, till this number of elements, and for the rest of the one, I have a map which contain these number of elements which have a distinct element, right? And how we can check, uh, for after this particular this element which we have taken last, we just simply check the rest of the elements and the size of the map, right? uh, the size of the if the size of the map is equal to the number of remaining elements, which indicates that our array is distinct. Otherwise, if the size of the map is less than, which indicates that's which indicate that we have a number of elements but the size of map is less than. For example, in this case, what if the like this, right? So we stop at this point, number of elements is 4, right? But what the size of the map, it is still bit 3, right? The size of map is still be 3, but we have number of elements 4. So in this scenario, in this such case, we know that we have to remove more elements in order to like form array which contain only a distinct number of elements, right? So we don't have to do a lot of things, we just have to iterate over the array, just following the simple sliding window approach while making a size of 3. And every time we make the size for the rest of the element, we just check how many elements we have remaining and what's the size of the map, right? With this, we are able to solve this particular problem efficiently. And one more thing that they have mentioned, that if there are fewer than 3 elements, all the remaining elements are removed, right? So we should have also have to like we would also have to manage that particular case as well. So let's see the code, how we actually approach this particular problem. So if you see, as I know, we need a number of like the elements and their frequency, which actually help us to figure out that if the number of elements are distinct or not. This is the base case. What if all the number are distinct? So in such scenario, the size of the map is exactly equal to our n. So where in this particular scenario, we do not have to perform any number of operation. So we simply return 0. Then I'm just doing a sliding window. It's a standard approach. I'm just checking for the number because it's in Java, if you do not have a number contains, then it return a null value. If map.contain, then I'm just simply reducing the frequency of that particular element. And if the frequency becomes 0, I'm just simply removing, because it is not going to contribute to my answer, but having that number in my map going to uh, like cause some issues to form a right answer. And every time just checking the window of 3, if I reach, that means I need one of operation, because I have performed this number of operation, right? So I reach this, I just reschedule my window. What it mean, let's say I have this array, right? So let's see, it's 0 1 2 3 4 5, right? So I have reached till this point, the value of j is 2 and the value of I is 0, right? So I have reached at this point that my window size become 3. Let's say there are some elements, let's say 8, and right. So as you see, even after removing this particular array, we still have elements which are not distinct. So in such scenario, what we have to do, we just have to like again form a window of 3, so that we can remove those elements and figure out if the remaining elements are distinct or not. So how we can remove the value of I, right? Like how we have to increment the value of I even after removing this, if array is not distinct. So what we do, we just simply put our I pointer to point this particular point, so that our new window start from here, right? Because in general cases we simply increment it based on certain size, right? In this case we have a 3, so we simply starting our I pointer to point this particular value and pointing the j pointer to point the same particular value, and then forming another window. With the help of this, we can simply able to find our window of size 3 and calculate the results. Here what I'm checking is, I'm checking if the map size is equal to the number of remaining elements. If remaining elements are equal to the size of the map, in such scenario we have reached the point where we have removed the elements and now we have only the distinct element present in our map, right? So we simply break out from the loop. But if it is not the case, then we simply repeat this particular operation. And here's the thing: what if the number of elements inside the map is become empty, like map becomes empty, but still we have a window of some elements, right? For example, in case of 2 2, our map size is 2, but still I have one particular test case, right? So this is the one of the case like where if the map size becomes 0 and we still have some elements to process because the window is less than 3 and we haven't visited this particular part. So in this scenario we need one more number of operation, and here I'm just like, for example, if I have 2 right, so I have removed this element but I haven't touched this particular test case or this particular section, right? But my map become empty, but map become empty, but still I pointing to 0th element and j pointing out of the loop, right? So in such scenario we haven't performed any number of operation, which means both elements are equal, so we require uh, one number of operation because the length of the array is less than 3, right? So this is the case which we are actually handling over here. So this is the piece of code. Let me just run it once. Okay, I made a little mistake over here. Yeah, so talking about the time complexity, right? So time complexity is going to be uh, OFN in order to fill the map, and it is also, you can say, not exactly the OFN, but every time we are creating the 3 size, but even we are iterating over every elements, right? So it is also OFN. So O of n plus O of n, which is equal to O of n. Talking about the space complexity, so which is also often because we are using map over here and storing all the elements, so that's why the space complexity is so often. So this is it about this particular problem, and I hope you understand the problem. If you understand the problem, please like the video, drop a comment what you actually understand about this particular problem, and I hope you learn something new from this video. And until then, bye bye, take care.